Geologists believe that about 5 billion years ago, long before life as we know it existed, the Earth was made up of very hot liquid or molten rock. We call that rock magma. The young Earth was a fiery inferno, constantly bubbling over with gases and this hot magma. Over millions of years, this liquid rock cooled and hardened on the surface, yet stayed hot and liquid underneath. As the surface cooled and hardened, hot magma from below would break through the crust in the form of volcanoes, creating more land each time it cooled. This cycle happened again and again until large land masses were formed. As these volcanoes erupted, they also emitted gases and steam which rose into the atmosphere, cooled, and fell as rain. So much rain fell that it filled the depressions in the Earth's crust, forming huge oceans. Only the highest portions of the crust remained above the water. These large areas of dry land are called continents. Over time, great forces from below the surface of the Earth caused the crust to crack. The Earth became like a giant jigsaw puzzle. Geologists refer to each piece of this puzzle as a plate. Geologists think that these plates have been constantly moving since they formed. At one point, approximately 250 million years ago, several plates collided in such a way as to cause all the continents to bunch together, forming one giant supercontinent called Pangaea. As the plates continued to move, Pangaea separated, and the smaller land masses moved into the positions we recognize today. It is important to realize, however, that the plates are still moving, perhaps only an inch a year.
Wellesley, Massachusetts. People have lived here for centuries. It only officially became the town of Wellesley on April 6, 1881. Its geologic history, however, is a lot older than that. The rocks and formations we see date back as many as 600 million years ago.
The rock which forms the Earth's crust is called bedrock. It is the solid rock that underlies all soil, sand, clay, gravel, and loose material on the Earth's surface. In different places, the bedrock may be buried deep underneath the dirt, or the soil can be very thin, barely covering the base rock. In Wellesley, bedrock is very close to the surface. As you drive around the town, look for the rock outcroppings, the places where the bedrock shows through.
The first stop we are taking is at Devil's Slide. Between 600 and 650 million years ago, the continents are bare. While there is life in the seas, life on land does not yet exist. Earthquakes and volcanoes tear the land apart. The continents are drifting and colliding, breaking and forming. Igneous rocks are being formed deep underground. These rocks become some of Wellesley's oldest rocks. As you walk toward the slide, notice the rocks on the hillside. What do they look like? What type of rock are they? What colors do you see? Do they have big crystals or small crystals? What do you notice about this rock? How is it different from all the rocks we just saw? What colors do you see here? Do you find the pink feldspar? Which rock is older? The diorite intrusion and the surrounding granite are some of the oldest rocks in Wellesley. They formed deep underground with miles of hard rock above them. Much of the granite has been weathered away and scraped by the glacier as it passed over New England. It came from the northwest and was slowed down by this large rock. The glacier passed slowly over the hard diorite, smoothing and polishing it. The glacier then sped up as it passed over the knob, breaking off pieces on the downside. As you climb the rock, you will see lots of evidence of weathering and erosion. Look for the roots of the trees. What is happening to the rock? What story can you tell about what has happened to the diorite since it was formed? What signs of weathering can you see?
Notice the marks on top of the rock. These are examples of glacial scarring, marks and scars made in the rock by debris carried by the glacier.
Notice the scarring on the other sides of the rock as well. Look for the date carved into the rock. This date was carved into the rock over 100 years ago. Do you think people will be able to see it 100 years from now?
The next stop we are taking is at Hemlock Gorge. We move ahead in time, perhaps only 50 million years or so, and fast-moving streams flowing from mountains carry rock pieces to the ocean. The planet is still a barren place with no plants and animals, only a planet in change. Rounded stones, both large and small, are carried by the streams and deposited in sand. The sand and rounded rocks harden into conglomerate form. It was first identified in Roxbury, Massachusetts. Since the rounded rocks look like round raisins in pudding, they called it Roxbury Pudding Stone. Geologists know that the mountains were in Africa. These rocks were part of Africa when the sediments were laid down and then compressed under the sea to form hard rock. During the earth movements, the rock was not only exposed at the surface, but tilted, so the layers are no longer flat. When the plate movements caused the continents to collide, the west coast of Africa bumped into what is now North America. When the continents later separated, part of Africa was left stuck to North America. As you explore Hemlock Gorge, look for places where it looks like the older rounded rocks fell out of the surrounding sandstone. Look at this formation. What does it look like? What might have caused this shape? At one time, the river going by here was much higher. The slowly flowing water caused rock material to gradually wash away. Weathering, the breaking down of rock material, led to erosion as the dislodged pieces of rock were carried away by the flowing river. The force of running water is remarkably strong and causes many changes to the landforms and rocks of the crust of the earth. The cave at Hemlock Gorge is just one example of the strength and effects of that force.
Our third stop will be at St. Mary's Cemetery. It is hard to imagine the scope of geologic time. The rocks at Devil's Slide were formed over 600 million years ago. The rocks at St. Mary's formed around 100 million years later. That is still over 500 million years ago. There is still no life on land, only rock. Volcanoes erupt, breaking up the rock that has already been exposed to the Earth's surface, breaking up its crust. Over time, these newly formed volcanoes either erode away or are broken up by new volcanoes. Old rocks become embedded in new rocks age and become the rocks we see now, hundreds of millions of years old. During a volcanic eruption, lava moves up through a crack in the bedrock. This crack is called a chimney. As the lava flows up through the chimney, pieces of the original bedrock break off and are carried in the lava flow. The lava in the volcanic cone cools. Over time, the lava that erupted at the surface to form the volcanic mountain erodes away. What is left is the part of the lava that never made it to the surface, but instead hardened under the ground with pieces of bedrock embedded in it as it cooled. At St. Mary's Cemetery, we see part of the plug of an old volcano that has been exposed at the surface. The plug itself was much bigger. The rock we see here is only a small part of the outcropping. Years later, the rock was scraped and smoothed by the glacier as it passed over the area. As you explore the rock, look for this little gully. What would have caused this channel in the rock? Can you imagine the water flowing over the rock, gradually smoothing and polishing the stone? Look for the different colored rocks. These were part of the original bedrock pieces that were broken off as the lava flowed to the surface. Some of the rocks show signs of being stretched and pulled by the heat of the lava. This rock, like the rock at Devil's Slide, shows signs of glacial scarring. Imagine all the different forces that have acted on this rock.
We move ahead in time from hundreds of millions of years ago to less than 1 million years ago. We have moved from bare continental rocks to when plants and animals began to live on land. Pangaea, the mega landmass, has broken up. Gradually, the continents have moved to their present locations, leaving part of Africa hitched to the east coast of the United States. The dinosaurs have come and gone. Much of the northern portion of the world has alternately been covered with glacial ice and then uncovered again during interglacial periods. The last two glaciations reached the New England coast about 55,000 and 18,000 years ago. Everything was covered with slowly moving ice, even the tops of tall mountains. Like a frozen river, glaciers move slowly along moving rocks and change the shape of the land. Many well-known geographical landmarks like Long Island Sound, Block Island, Nantucket, and even Cape Cod were created by glacial action. A glacier could be up to a mile high. As the ice sheets advanced, they scoured the landscape. Plants and animals were driven far south. As the ice retreated, it left debris, sometimes isolated rocks, and sometimes huge accumulations of rocks, sand, and silt. Imagine being at the bottom of the glacier, with glacial ice above you and on both sides. A crevasse, a crack, often formed in the ice. Melting water dripped down the crack, Streams of meltwater flowed along the bottom of the glacier, carving a tunnel in the ice. Rocks of all sizes and sand were carried along the stream under the ice. Some years it was colder, the stream stopped flowing, and the rocks were frozen into the stream. Later, when it warmed, the rocks would drop as the stream began to flow again. The water would flow on top of the newly formed stream bed, carving and melting out new space in the ice. Finally, after thousands of years, the glacier melts away above the stream bed, then the sides melt away. The remaining stream bed, called an esker, was left as a ridge of debris rising above the surrounding land. As with most streams, the ridge meanders and does not follow a straight line. This brings us to our fourth stop, Longfellow Pond. As you walk up the path to Longfellow Pond, look at the variety of rocks. Here you'll find rocks of all types. Rocks from further north, which were carried along the glacier and left behind. How does the variety prove that a glacier created this geologic formation? When you get to the top, look down both sides. Imagine what this would look like with no trees. Imagine this ridge as seen from the sky. As the glacier advanced, moving from Canada across northern New England to Massachusetts and onto Cape Cod and Long Island, it scoured the land, picking up and moving everything that it could. Larger rocks were too heavy to carry very far, and they were often dropped only a few miles from where they started. These large rocks are called erratics, and New England is covered with them. As you explore Fairy Rock, notice the size of it. What would it take for us to move this rock? Do you think if everyone in class tried together, you could move it? I doubt it. What does this tell you about the power of a glacier? Can you identify this rock? What are the white bumps on the surface? As you look at the rock, look at the pink crystals. Look at the size of this feldspar. What does this tell you about the conditions under which the feldspar formed? Under what conditions do large crystals grow? As you continue around the rock, notice the differences in the rock type.
What do you call this when a rock of a different type forms in existing rock? Look closely. There's an intrusion in the intrusion. What does this tell you about which rock came first, which formed second, or even third?
As the glacier retreated, melt streams carried rocks and sand, depositing them like river deltas. Sometimes chunks of ice broke off. The melting streams flowed around the ice, leaving sand and rock particles all around it, sometimes even burying the chunks of ice under the debris. When the chunks of ice finally melted, the sand and debris settled and left a round depression called a kettle hole. These depressions could be quite large. Many of them still remain today as ponds, or small hollows filled with water.